صباح الخير واهلا وسهلا بكم. بالبدايه راح احكي باللغه العربيه then I speak in English. اهلا وسهلا بكم في المهرجان التكنولوجي الوطني ال11. اهلا وسهلا بكم بالمحاضره الرئيسيه اللي بنلقيها ضيفنا من البرنامج الزائر المتميز من IEEE كمبيوتر سكيل. هذا الضيف بستضيفه مجمع المهندسين الاردنيين في فرع الاردن، ونحن سعيدين جدا بوجودكم وفي هاي المحاضره اللي راح يلقيها الدكتور. اسمحوا لي اني اتحول للغه الانجليزيه. Ladies and gentlemen, it's my great privilege to introduce Dr. Kostas Karpouzis, our keynote speaker in today's session on emotions, games, and interfaces. Dr. Karpouzis is an assistant professor at the Department of Communication, Media, and Culture at Pantheon University in Athens, Greece. Dr. Karpouzis has a rich background in communication and computer systems, having served as a research director at the National Technical University of Athens for nearly 2 decades. His profound research in emotional modeling and recognition has been supported through numerous Greek and European projects, notably the Human Network of Excellence and the award-winning FP7 project. Currently, Dr. Karpouzis is a prominent member of IEEE Explainable AI Working Group, aiming to set standards for transparent and understandable AI systems. He also plays a key role in IEEE Greece, contributes to national and international ethical committees, and serves on editorial boards for several renowned journals. An advocate for science education and public engagement, Dr. Karpouzis is deeply involved in initiatives like Game Lab Greece and Go Coding, and has inspired audiences across the globe, including TEDx Athens. Please join me in welcoming Dr. Kostas Karpouzis as he shares his insights into the intersection of emotion, gaming, and user interface.
Thank you so much, Professor, for the invitation, your hospitality. I would like to congratulate you for organizing the technology parade. I have been to science fairs in quite a few universities, and I have to say that the level of research indicated in the projects conducted by your students, of course, and observed by your fellow lecturers, is quite impressive. And also, it's very difficult in similar situations and organizations to motivate as many volunteers as you have. So again, I will have to congratulate you, not only for the level of the presented research, but also for the amount of people that you have mobilized and the quality of this event. Hopefully, it will serve as an example for the whole region, since you also mentioned my involvement in Region 8 and in computer society. So about the topic of my presentation, I'm going to discuss actually how games are related to culture, both as a sort of mirror of the culture that we live in, the culture that is actually included in the thoughts of the designers and the choices of the designers and the mechanics that they choose to include in the games, but also in the way that we play those games. So if you go back a few years ago, you might see that The mechanics included in the games that we played in 2010 or maybe even earlier were kind of different to the mechanics that are included in the games that we play these days. And this, of course, makes total sense because, as I said, it's a reflection of the aims and of the targets and the objectives that each community and each society has. And also it has to do with what players want. So in many societies, you see, for instance, a rapid increase in casino or card-related games, which of course, again, makes sense because quite a few people would like to try their luck in such activities. And of course, the COVID pandemic and the movement restrictions helped in that effect because we couldn't actually go out and play in casinos or play cards with our friends and so on. So we had to find a mobile solution. On the other hand, a major part, and I think it's also reflected in the companies that sponsor this great event, a major fact that actually comes from too many players and too many users playing games has to do with the amount of data that we can collect from those users. For instance, you may see yourselves, okay, consider your everyday routine. Some of you play games on personal computers, on desktop computers. Some of you still have consoles. You are becoming the minority as we speak. But most of you play games on mobile phones, and you play them all the time. You play them while you wait for the bus. You play them in class if you're bored by a lecturer. You play them while there's nothing on TV or Netflix or something like that, or you're waiting for something to download and so on. So we try to fill our free time with gaming. And as we do that, it's not only that we entertain ourselves, it's, as I said earlier, we are contributing information about our playing style, about what makes us happy, what is engaging and appealing for us. And this is, okay, I was going to say exploited, but it's a bad word. So the companies out there actually utilize this information to make our experience better and, of course, more profitable for them. And then towards the end of my presentation, I'm going to discuss the uses, some of the uses of artificial intelligence when it comes to adapting the player experience or the content utilized by the games to make them again more appealing. And I'm going to discuss it in the context of two major projects that I was involved in. One of them was called Siren. It lasted from 2010 to 2013. Both of them were funded by the European Union. So Siren is the screenshot that you see at the bottom of the slide. It was a game targeted to children aged 10 to 14 years old. And it had to do with educating and helping them with respect to conflict resolution at schools. So emotion was a major part of this player experience, of course, and of course the design process. And the other game that is shown at the top right of the slide was called Navigo. It was produced around 2018, and it had to do with language learning at the early levels. And the innovation of this design and development process was that not all players played the same content. So a major issue with most learning labs, I'm sure you will think about Duolingo, but Duolingo is a quite recent application. And of course, it's a very powerful application because we contribute, again, all our data and some of us pay for it. So most language learning apps use the same content for all levels. And even in the same level, they use the same words or sentences for prospective students to try and dictate them or write them in a better manner and so on. So what we did in Navigo, and I'm going to discuss it in more detail later, was try to break down the four major languages. It was English, German, Spanish, and Greek. Okay, I realize that Greek is not a major language, but because we participated in the project, we had to work with Greek. So we broke down these four languages into their individual details. The different parts of the language that young learners should start from. Individual sounds, individual writing phenomena, individual spelling phenomena, combinations of sounds, and so on. And so we built a database of different kinds of content, mostly words, but also sentences. And we produced and selected specific content for each specific student according to their expertise. So the first part of the title of my presentation has to do with culture. Some background information. So my PhD is in computer science. I did emotion recognition from videos. So you can imagine that I spent hours and hours watching videotapes of people discussing with each other, trying to identify their emotion. And I use the word videotapes because I am that old. Okay? Most of our data at the time came from videotapes. So one of the prominent theories regarding emotion is that there is a number of specific emotions which are universally recognizable across different cultures. If you have access to Disney Plus, there's a very interesting TV series called Lie to Me. The inspiration for that TV series is the work of Paul Ekman, who is a very prominent and very rich these days psychologist in the United States. And he came up with this theory. So he said that if you have a picture of someone smiling and you show it to a Western European, a person in Jordan, and someone in the Sahara, for instance, they will come up with the same label for this emotion. They will say that this person is happy. Of course, that doesn't necessarily have to do with what that person is thinking, because sometimes we smile when we are sad or angry or whatever, okay? But the indicated expression is the same. So after I finished my PhD, I actually got somewhat bored from watching all these videotapes and trying to write MATLAB code. I'm mentioning MATLAB because MathWorks is one of the sponsors of this event. Trying to write MATLAB code to analyze the frames of these videos. And I also needed actually an excuse to play games while in the workplace. So I started thinking whether we can actually identify and analyze the emotions illustrated by gamers while they play. And this is actually very nice because we have specific emotions shown by game players. And we also have the opportunity to motivate, to elicit their emotions. So if you go on YouTube and look for funny videos with gamers and game players and so on, you will see people screaming, people fighting, people laughing uncontrollably. We don't do that in our everyday life. So we find, after monitoring people, after recording people who play games, we find that games actually are a very powerful emotion elicitator for the players. And we can actually use this information, as I said in the beginning, to sort of adapt the player experience and make the games more appealing to them. So as a general rule, I have a very general and vague definition of what constitutes culture. But I wanted to include and discuss this general definition to state that in most cases, we think about culture as looking into the past. Okay, Greeks, we are constantly attached to our past. Okay, we think that we are the descendants of Alexander or Pericles or Socrates or I don't know what. And we forget about the culture that we create every day. So maybe you've noticed last weekend we had the Eurovision Song Contest. Regardless of whether people like those songs and the outfits of the singers and the dance maneuvers and so on, regardless of that, this is actually a very nice specimen of modern culture. Games are also a specimen of modern culture. You can compare, as I said earlier, the games produced in the 80s with games produced around 2000, like Grand Theft Auto, and with the very realistic games that we play these days either on PCs or on our mobile phones. And if you do that, you will see, for instance, the different means that we use, for instance, to portray women. And this again reflects a shift in our society about the role of women, the power that we may give to them, the role that they are expected to have. One prominent example has to do with one of the games of the Super Mario franchise. You know, Super Mario, the little plumber with the mustache, he wants to free Princess Peach from the castle and so on. So at some point, Nintendo, who is the maker of Super Mario, wanted to branch out of platform games, and they wanted to make a game with a richer story. And they made what is called an RPG game. So it's a role-play game. It's like an adventure game where action is not so intense, and you don't have to think very quickly. You just have to think into the future and make decisions that will reflect your progress in the game later on. So again, it was Super Mario who was the protagonist, the main actor of the game. And there was also mention of Princess Peach, who waited for Super Mario to free her from the castle. And of course, what was expected from Princess Peach, I remind you, she's a princess, not an everyday woman. What was she supposed to do while she was waiting for Mario? She had to bake a cake. There was nothing else for her to do. So these days we see games targeted towards women, targeted towards, I would say, everyone. They are so inclusive that everyone can play them. We have games with multiple characters, so young or not so young gamers can identify with them. And then, as I said earlier, these actually reflect the different qualities of our societies, and you can see the evolution and the change. Of course, evolution is not always a nice thing, but it's a thing that we observe in nature. Another important and very interesting fact about games is that it's actually our first job when we are very, 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 very young. So when we have to, when our parents want us to be, involved in some activity, they usually take us to a playground. Maybe they can arrange a play date with someone else who also has children. And we actually interact with someone we don't know, and maybe in some cases we will never see them again. And we also interact with children that are much younger or much older than us. And of course, for instance, a 3-year difference between a 2-year-old and a 5-year-old might seem very little, but for them it's a great divide. It's not the same with a difference between, I don't know, 27 and 30 years old, which is practically not existent. And we also see, and this is something that we noticed after discussing the games played by immigrants arriving in Greece, that even though the children of immigrant families came from distinctively different cultural backgrounds than the Greek ones, especially the modern Greek ones, the mechanics and the actual objectives of the games that they played in the playground or at school or at home, I'm not necessarily speaking about digital games here, they were pretty much the same. Maybe they would play the same game and call it differently, which of course makes sense. Maybe one of the games would be competitive while the other one would be cooperative, but then still the mechanics would be the same. But we saw the same, I would say, means of cooperation and means of winning the game and implementing a strategy and then evolving it to become better. So what we do, especially in the first years of our lives, is try to integrate play in our everyday life, especially at school. There's an issue here, especially with, I would say, societies which are very slow to evolve and adapt. In some cases, those societies view play or game as antagonistic to learning. So the usual phrase used by Greek mothers is stop playing and start studying, in different versions and different intonations and different volume or something like that, which of course is a very sad thing, because we are trying to promote, and your projects also do that, we're trying to promote the idea that learning should not be antagonistic to play. There's actually a very nice quote by another American psychologist called Stuart Brown. Stuart Brown gave a very interesting talk, I think it was back in 2008 in TED, and he talked about the opposite of play. There's also a book with the same title. And he says that the opposite of play is not work. So when you don't play, you work, and when you work, you don't play. So the opposite of play is depression. Okay? And of course, It doesn't mean that when you go to work, you should play cards or backgammon or whatever, okay? But you should find the same mechanism to motivate you, the same mechanism to actually reward you for doing your job well. For instance, when you hand in a very nice project, you get nice grades. This is the same scoring mechanism that we use in games. Okay, you may have heard the word gamification for this. So gamification is when we try to utilize mechanisms from games in other activities which are not games. So as I said earlier, a nice feature of games is that they lower social barriers. I have a screenshot there of someone who just lost in a PlayStation game, so they threw away the controller. There's another very funny video, funny for us to watch, not so funny for the participants, of a couple playing a game on their couch, and the girl loses in the game, and she stands up, she starts yelling, which, okay, it makes sense. It happens every day. You see people yelling at the street, football stadiums, or whatever. But what she does next is pick up the Xbox and smash it into the ground, which again, I think that this is not something that people would do. Another important fact about games, I talked about the interaction with young children. Maybe we don't know each other, but we will play a game easily and have a good time together. This also happens with young adults or older people. Okay, some people will go to the basketball court without knowing someone. They will try to join a basketball game and play just to have fun. They're not going to win a championship or anything. They just want to have fun and have a good player experience. The same holds with online and multiplayer games. In most cases, you don't know the other person that you play with. I think that the vast percentage of games these days is online and multiplayer because, again, it's motivating. And it also relieves some of the stress from game development companies because it's not very easy to make a decent AI for your game to play. So you just hire, sort of, quote unquote, someone else to play the opponent. But we see people, forming groups. There's a concept of clans in some multiplayer games. There's a concept of putting together team members with different skills. Someone is a mage, a magician, so they're competent in spells. Someone is a warrior. Someone is a tinkerer or a builder or something like that. And this can reflect also the skills and the psychology and what makes it motivating for the people who control these characters. So I'm not very proficient in games which require fast action, so I will assume the role of a tinkerer or a builder or something like that. Or maybe now that I'm older, I will become the mage because, the only thing I can do is cast spells on my opponents. But I'm not going to win in the game by myself. I need to find a team with complementary skills in order to attack the different game objectives. And this is, of course, the same in life. So we can use games to actually introduce young people to what they should do to succeed in life in terms of cooperation and working together. And this has to do with a game that I mentioned earlier about conflict resolution. So the first part of this design process has to do with finding out what is important and what is appealing for the players. And this process is called player modeling because, of course, it's not very easy to create a game that adapts from day one to the preferences and the playing style of each player. So we'll have to assume that we're targeting a specific group of players. So if you're making a game like the Montessori game that I showed outside, you're expecting the vast majority of your players to be very, very, very young children. So you design for them based on their characteristics and preferences and the way that they prefer to learn. If you're making, I don't know, a fighting game or a game with zombies, you can expect that your players will be young adults, for instance. Whereas if you make a card game, you cannot expect anything because all of us like to play card games. So you cannot assume that you have a specific player model in mind. One of the very important issues for game designers and game development companies has to do with adapting the difficulty of the game. Because as I say here, if the game is very easy, then it will quickly become boring. It will not be challenging for the players, so they're going to drop off. And imagine going into Play Store or App Store and looking for games. You see that every day you have hundreds of new games. And I'm not talking just the AAA titles, the important titles, the franchise titles like, I don't know, Assassin's Creed or FIFA or whatever. I'm even talking about what we call indie games, games produced by small groups of people. So you have huge competition just to get people to download their game, download your game into their device. And you also have competition between different applications which use notification. You haven't played this game. It's been 8 hours since you, I don't know, unlocked the chest in Clash Royale. You should come back. You know, different people trying to pull your clothes to attract you towards their direction. On the other hand, if you make a game that's very hard, and this has to do not only with the objectives, but mostly with the mechanics, the combination of controls, the timing, how forgiving the game is. If you lose, just if you make one mistake, then it's going to be annoying. And then again, also the players are going to drop out. This has to do again with the information that players provide as players. So we have the information which has to do with our behavior in the game. We use keys, we may use joysticks. We wait in a particular point of the level for X amount of time, for X seconds. When we lose a life, we give up the game and play again, I don't know, the following day or so on. Or we persevere and try a different strategy. Sometimes we spend money on games just to buy an extra life or just to buy a weapon or just to buy something that is merely a cosmetic improvement, as we say, some clothes or some gadget or some sunglasses for our hero. So besides this, we also have the performance data, which mostly has to do with the performance of the device that we use. I would say that the majority of the popular games are 3D games, which are very costly in terms of computing power. So they would need a recent device, especially in the case of mobile phones. And in some cases like Fortnite, they would also need a decent graphics card, which in turn, of course, needs some sort of investment from our part. So what most gaming companies do is try to monitor the performance of the game. For instance, the amount of frames shown every second to the players, or the lag that its network infrastructure has. Because it's very important, if you have a fast action game, a fast-paced game, it's important for all players to have the same view of the game world at any time. If someone lags behind, then they may be killed, or the others may produce other actions and progress in the game, and so on. And of course, the most important thing has to do with revenue. Given again that most of the games that we play are free to play, we can download them on our device, mobile phone or a PC for free, but those companies have to find some sort of revenue. And it's important to remember that games are very expensive to produce because they actually combine the costs of making a software project with the cost of making a movie or a TV series or in general a narrative work, because you have the scenario, you have the different artistic forms of content and so on. And you also have to make it work on different devices. And especially in the case of mobile phones, this was easier like 15 or 20 years ago because there was just one iPhone. So everyone would develop for this. And there was, I don't know, 3 or 4 or 5 different Android phones, mostly produced by Samsung and Xiaomi and other major companies. But these days you have different versions of iPhones with different screens and different processors and different memory sizes and so on. And you have a million different Android devices. You even have smartwatches, or you have fridges with Android screens, which of course some people would try to play games on. So it's actually a nightmare to try to design for different devices. I suppose that Jawaka, who's outside, has more to say about identifying trends and patterns in spending money when it comes to players. But one major line of research, which of course combines games with data science, has to do with predicting player behavior when it comes to in-app purchases, to spending money in the game. So it doesn't have just to do with the points of the game where you should offer them a power-up or offer them additional time to complete the level or a new weapon. It also has to do with whether they are on the move, they're on the bus, on the train, whether they're at home in the afternoon or evening or late at night. So what we're trying to basically do is try to study the players themselves and see whether it's possible to predict their behavior. A different source of information that we can use comes from what we call game or player communities. Reddit is the most prominent example of this concept, where people go online. Reddit it's a huge forum. It has forums, I don't know, from biology and science and computing all the way to, I don't know, creating different forms and different substances in Minecraft, all the way to cooking, or I don't know, even world peace, I suppose. Okay. So each major game starts its own community on Reddit, and even the major companies hire what they call community managers to try to actually monitor the interaction between different players and actually listen to the voice of those players. Because, as I said earlier, one of the major objectives of game development companies has to do with adapting the game to suit the preferences and the likes and the behavior of their players. So we do have some sources of information, as I showed earlier. So if you see that, for instance, your players are moving away from the game and they don't really play it, then of course it's a major, red flag that you should do something. But you can also get free information from online sources. So you can do some sort of sentiment analysis. For instance, you can have now easy to use Python libraries to analyze the sentiment shown in online forums. So you can see whether the reaction of your players and the participants of those communities is positive or negative. You can also do what we call social network analysis. This is, of course, a line of work that started with Facebook or Twitter or other, maybe Instagram, other social media, and has to do with finding specific users whose message can travel quite far, who are what we call influencers, okay, mostly on Facebook. And the idea is that we can attract those influential people to promote our game. And this is actually, I think, the most usual means of promoting a new game these days. So we don't have print magazines. Nobody watches YouTube ads anymore. So we go to some people that are followed by millions of users, and we ask them to play our game for a few hours, of course, for a good amount of money, for a few $1,000s. And this was actually, I think, the case with Fall Guys. Fall Guys was a game that was hugely successful during the pandemic, and it became successful because the production company hired one of the most influential YouTubers of that time to play the game. So it was actually an instant win, just to use the gaming terminology. I mentioned behavioral metrics. This is a screenshot of an actual game. It was called Replica Island, but from around 2000, I think. The different colors that you see there correspond the points of the level where players lose. So red points, red pixels, correspond to places where they usually lose, whereas the other colors correspond to other parts of the stage of the level where it's not very common to lose at all. And you can see that those very dangerous parts of the level have to do with jumping, with avoiding enemies, with collecting different coins from the level, and so on. So what it is that game development companies do is go back to study these statistics and see if there are specific parts of the level that their players cannot go through without losing. So if there's one particular point like this, then the level designer should go back and fix it, because, as I said, if a game is impossible to beat, then players will drop out, actually. Another similar approach can be seen again in this Super Mario clone, where we can monitor the neighborhood of the player every time. So in this case, because Super Mario can pretty much jump and run and go everywhere, it's not very easy to monitor the specific parts of the stage where the players lose. So what we do is monitor what's around the player every time. And we only use a limited amount of pixels or cells around the player because the screen is quite large. And if you played such games, the screen moves with you from left to right. So it's not very easy and very convenient to monitor the whole stage at one time. And it also doesn't make sense because if there's an enemy far behind or far in front, then I'm not going to see it unless I reach that part of the level. And we can also monitor, as I said earlier, the different parts of what constitutes player behavior when it comes to low-level actions, such as using the different keystrokes or the buttons or going front and back and so on. And this is also important because in some cases, we want to show some pieces of information to the players, go this way or pick up this tool or pick up this, I don't know, coin or power up or something like that. And we can see that players actually miss that information because they don't react to it. This is very handy when you want to show players that, for instance, their time is limited and they should act quickly because the game is close to an end, or when you want to show them that they're losing health, so they should get a health pack or something like that. So it's important to see if our means of passing on information is quite effective. And speaking about health, this is a health pack from a very, very, very old game called Doom. Of course, it's also remodeled and revisited these days for modern computers and even refrigerators. This is a health pack. Of course, you can predict its behavior. When you're low on health and you're pretty much close to dying, you get a health pack and you replenish your health. So I use this image to say that, okay, the first part has to do with collecting the data. It has to do with identifying specific patterns or specific means of interaction that we want to improve. And this part has to do with actually the actionable part of this process. So we see that someone is close to dying, then we can generate a health pack for them to keep playing. Or if we want to promote a specific playing style, for instance, you know, games like Doom are modeled in buildings. So you chase around different enemies, other enemies chase you and so on. So imagine this very nice room being modeled as part of a game world. And you want to actually force your players to go through here. What we usually do is put something very valuable for them. And once they identify where that particular item lies, then they will always come here. So if you have a very special weapon for them, or if they know that these health packs will spawn at the same place every time, then they will use this room. If you want them to avoid this room for some reason, then you can, I don't know, spawn maybe some enemies, which are, I don't know, very hard to beat or very hard to kill and so on. Or, of course, spawn nothing, create nothing in this place. Again, it's sort of a decision that game designers have to take. And this is actually one of the major differences as a narrative work that games have with cinema or TV or even books. Because once you've written a book, then you can do nothing to adapt or change the player experience or the user experience or the viewer experience. But in games, you can do that every time. If you want to change the behavior of your players, or if you want to guide them towards a specific place, then you can actually adapt the experience and create items or create objects or create enemies to make them go that way or avoid that specific room or part of the level. This is a screenshot of my favorite game. It's called Clash Royale. So it kind of resembles chess in the sense that you have different units like soldiers, like buildings and so on, and you place them on sort of a chessboard. But the thing here is that each unit has different properties, as you see there. The number 4 in the purple dot at the top of the image next to the image of the musketeer has to do with the cost of each unit. So when I place each card on the board, I have to take into account the cost because I cannot spend too much elixir at any point. And I also have to take into account the other numerical properties at the bottom of the screenshots, which have to do with its strength, which is stamina, with the what we call damage per second, how fast it shoots, and so on. So companies like Supercell, who is the producer of Clash of Clans and Clash Royale, their favorite means of getting money from the players is to create new cards. So if they create a new card, then I have to spend money to improve its statistics, to collect new cards and level up to the maximum level. Of course, this leads the players to, in groups, use the same card. So effectively, if I use, for instance, Musketeer, then I have a guaranteed 80% chance of winning, which does not make sense because at the end of the day, everyone is going to use Musketeer, that particular card. So what gaming companies do is try to, as they say, balance the different statistics of the cards. So imagine, for instance, in chess, where you can have a version of chess where the horse does not go for 3 blocks away. They can, I don't know, teleport to the other side of the board. If we have chess players among us, I'm sure I'm not their favorite person right now. So what we can actually do using the information that players provide is see whether there are actually cards which guarantee a high percentage of winning. And what we do is try to lower the statistics or make them more expensive to use in terms of elixir of the currency used in the game. And on the other side, if we have some cards that are not the favorites of players, then we can improve their statistics for them to become more popular. I briefly discussed about Paul Ekman and his ideas on emotions, just to state that we can actually utilize the knowledge provided to us by psychologists. But the thing here is that psychologists have not really studied gameplay behavior. They're mostly interested in the controlled situation of someone going to the psychologist and discussing and interacting and asking questions in a calm and controlled manner and so on. So we can start from the framework, the theoretical frameworks provided by psychologists, like the framework about fun and the fun factor by Nicole Lazzaro. But then we have to adapt them to the different requirements posed by games, again, as a narrative/software project. And Lazzaro actually suggested this 2-dimensional representation. So you have the vertical axis, which represents the similarity of the game to real life. So at the bottom, where it's close to life, you could have, for instance, a flight simulator, which we expect to be close to the real thing. And the horizontal axis has to do with whether there are specific goals which need to be met by the players. I need to finish that level. I need to pick up 10,000 gold coins and so on, as opposed to more open-ended games like prominently Minecraft. For specific genres of games like role-playing games, where again we have different actions that can be used and illustrated by the players, so they can actually adapt their player experience and behavior to their own specific needs and preferences. For instance, we have Richard Battle's modeling here. Battle actually divides the players in RPGs to 4 different qualities. So one of them has to do with whether we want to succeed with respect to the game objectives, whether we want to pick up all the treasures and the relics and defeat everyone else and so on. Some other players would just like to explore the game world, not necessarily because they want to find something, but they want, to actually respond to their curiosity, their natural curiosity, and so on. In any case, we have as players a specific amount of points or a specific percentage that corresponds to each of these 4 qualities. It's not necessarily someone, I don't know, 100% killer. It's very rare to find something like that. But someone could be 80% killer and then 10% achiever and then 5% of the different other categories. And actually, Bartle was not a big fan of monitoring players, mostly because his ideas and his theories came from the 80s and 90s, where we didn't have the internet, and videotaping players was very costly and ineffective and so on. So he came up with a very large questionnaire, which tries to imitate and ask people what they would do in specific situations in the games. So what would you do if you found yourself alone in a forest and attacked by, I don't know, this many enemies and so on? Of course, these days we can actually monitor the performance and the behavior and the choices made by the game players while they play the game. So we can actually come up with a profile and try to adapt the player experience with respect to that. This is a screenshot of a work that was published by our group a few years ago. So what we did, again, we were using a different game. It's a Super Mario clone. And I will tell you an interesting story in a while about why we use the clone and not the actual game. So we had players, actually students in our lab, play the game. And of course, you can see that we also had the camera pointing at them. And we tried to correlate the different values that we can extract from the camera, like the head motion or the degree of movement or the direction of movement and so on, with their choices in the game. So for instance, my colleague Eleni here, whenever she presses the button to jump, she also does this. Okay, and if, for instance, you have ever played a racing game, you may find yourselves turning the steering wheel and also turning your body like this. So our objective here was to try actually to predict whether a specific level would be interesting, appealing, and fun to play for game players. So one of the reasons that we actually chose to use a clone of Super Mario was that we didn't want to use the predefined game levels. We wanted to create the levels procedurally, because some players, like myself, are not very proficient, so they wanted to play a simpler level with not many jumps and voids and not many enemies and things to collect and so on, just going from left to right. Where others would find that particular level very boring, so they wanted to play something more interesting and with more opportunities for them to be killed and so on. So we asked the players to play couples of procedurally generated levels, and then we asked them not to rate their experience, but to rank them, which one they preferred, which one was more fun, and so on. So after collecting enough information and actually taking also into account their degrees of expressivity, as I said earlier, we found out that we can predict their performance in the game and their level of excitement and interest with around 85% success. So I'm going to go back to the Super Mario screenshot just to discuss what I said earlier. So there's a Super Mario competition happening in gaming conferences every year, like Conference of Games, ICC, and so on. And the idea, of course, is to make an instance of Super Mario guided solely by AI. So it's played by artificial intelligence. So the competition was running for, I don't know, 5, 6, 7 years. And the organizers got an email from Nintendo. So Nintendo is the maker of Super Mario. And the email was not angry, but it was written very carefully so as to be both strict and easy to understand. So they actually said that they have copyrights, of course, on the Super Mario character, but they also have copyright on characters who are plumbers and have a mustache. So you cannot actually create a game, I don't know, of chess or backgammon or a Fortnite character using this likeness. So what the organizers of the competition did was, of course, keep the mechanics and keep the level generation mechanism and so on, and use the Linux penguin as a character of their game. And moving to the final part of the presentation about generating content, I briefly discussed the iRead project, which produced Navigo. So the idea here is, as I said, to try to model the different phenomena that we find in those 4 languages, and try to start from the very basic, very initial, very introductive phenomena, and then build on those, which is, of course, something that sometimes happens at school, but you don't have the breakdown between different combinations of letters, different sounds of letters, different endings, and so on. So adaptivity had to do with choosing the actual content that players had to go through. I think I have. Okay. And then choosing the proper activity. So we had different mini games, very simple games, but we had to utilize the words or the endings or the prefixes for these words and so on. So it was kind of, for instance, if we want to try syllabification, dividing a word in its syllables, we had a laser mechanisms that players would use in order to break apart the specific word and so on. And besides single words, we also had some sentences with different words that students would have to arrange in the proper order. So the adaptation mechanisms actually had to do with selecting the feature to be tackled. I want content for words ending in ing, for instance. The words to be used, of course, again, words ending in ing, and then the particular game activity, the particular mini game to be used in this case. So what we did was actually take into account the degree of profession in these different features, and gradually present the students with more difficult content, more complex words, or more complex phenomena, and so on. And we did this in a way to sort of try to avoid, for instance, a mistake that was made by chance, or someone, telling me the answer and I get it right, so I get to the higher level, and then I cannot actually answer anything, and so on. So we used what is called the exponential moving average, which is a very, I don't know, complex name, but it's a simple idea because it's a weighted average that takes into account past attempts with diminishing with lower weights. Okay, so it's actually like a means, but you take into account more gameplay sessions. And the results was that we were actually mistaken in our design process. So what usually happens in those cases is that us as computer engineers started putting together some requirements. So we want to have this, and this feature in our game. And we didn't listen to the teachers, because at the end of the day, these games were supposed to help the teachers help the students. We were not trying to make games for the students to try on their own. We wanted to support the teachers. So this was one major mistake. Another issue has to do with the choice of technology. Okay, these days you have graph databases, you have vector databases, you have everything databases in order to actually store your data. We didn't have that at the time. So our choice of technology also actually forced us to take specific decisions during the design process. If you have to keep just one thing from this experience, this would have to do with listening to your users. So you're not making a game for yourselves, you're making a game for your users. Maybe it's an entertainment game, but you need to realize who is going to play, who is supposed to play. Is it me? Is it you? Is it a very young child? And you have to start designing for them, not designing the game according to what you like. So thank you for being here. I hope it was interesting, and of course I'm looking forward. This is my handle in most social media, and if you have any follow-up questions, I'll be very, very happy to listen to them.
Thank you, Kostas. I think we have some time for a few questions. We have until 1. Okay.
Thank you. This is a very interesting topic. Everyone is curious about. I wanted to ask you about a hot topic, which is data security. So we always know that if you not pay some other, so your data is being taken and maybe used in another commercial way. Maybe they're selling your data. Maybe you never know. So how can we protect ourselves with the gaming? Of game.
Yeah, okay.
So we download a lot of games, most of them are free, right? But they're making money out of it another way, based on advertisement, or what. They also have access to our personal data, like microphones, cameras, stuff like that. So from your experience, how can you guide us towards,
I will speak like a 52-year-old. Make sure you use games only from sources and game developers that you trust. So you cannot expect, for instance, a game made by, I don't know, Electronic Arts, EA, to do this kind of thing. I think it's the same with when you order from Temu. Because everything is so inexpensive, it's so cheap, they have to make money some other way. So they allegedly steal, as you said, your data and your credit card information, or they store cookies in your phone to track your behavior and so on. So, as I said earlier, games are very expensive to produce and maintain. So we have to take that into account. I would say, as I said, try to stay away from the urge to try a new game every day and stick with developers that you trust. Okay. I know I haven't answered your question, but I think that it's not very easy technology-wise, because again, allegedly, applications can start your microphone or start your camera without you noticing it, or even the very fact that you downloaded game X instead of game Y is one piece of information that can be used. So it's valuable information for the guys outside.
Kostas is staying with us in the parade, so you can talk with him later. Once again, thank you very much, Kostas, for this presentation. It was very interesting for me because he took us to places we usually go to, emotions, culture, interfaces, and games. Thank you very much, and join me to give him a warm. Thank you very much.
Thank you. Thank you.